It's math time with Heinz. It's math time with Heinz. Math time.
Hi everybody, welcome to lesson 6 here, where we're going to talk about linear functions again and how we can use them to model relationships. So let's get into it. This is kind of a continuation of lesson 5. So Central High School had 5 members on their swim team. And over the next several years, it increased by 10 members each year. So my swim team, S of X, equals, 10 members per year. That's my rate of change. 10 is my slope, and I started with 5 members. That's my initial amount, my y-intercept. And let's do the same thing for C of X. So the same school started with 35 members in their chorus, and they added 5 members each year. That's my rate of change there. Remember, per, each, every, those are key words that identify the slope. So I start with 5 members each year, and then I add on 35. Hopefully you got those two functions there, and they're in the form of y equals mx plus b. So a satellite TV company is charging a one-time installation fee and a monthly service charge. The total cost is modeled by this function here, y equals 40 plus 90x. So explain the meaning of x and y in the context of this problem. So what am I modeling here? I'm modeling the cost. So y is the total cost. And x, x depends on how many months. X depends on how many months. So you have to read through and kind of realize what's my input and what's my output of this function. Explain the meaning of the slope. So the slope is the coefficient of x. That's my 90. So my slope represents what? Is that the one-time fee or the monthly service charge? Well, slope is for each, for every. So for each month, the cost increased by $90. Every month, the cost increases by $90. The y-intercept, I'm going to use their words. That's the monthly service charge is the slope. That's the one-time installation fee. There is a $40 one-time install fee. Notice I'm talking about it in the context of the problem, which means I'm going back up here to the top and using their words. Okay, so the slope is a rate of change. The slope is a rate of change here. The slope is saying for every x, how does y change? How does my output change? It's a rate of change. So for every x, how is my y value changing? Whereas the y-intercept, I need you thinking of initial, starting, one time. Those are all values there that represent, those are all kind of words that represent y-intercepts. Initial, starting, one-time cost, whereas the slope is a rate of change. So during a snowstorm, Jamie noticed that there were 4 inches on the ground at 3 p.m. So this is going to be the point, 3 p.m., I have 4 inches, right? Time is normally an x value. I'm starting with 3 p.m. The output is 4 inches of snow. And then I have 6 inches of snow at 7 p.m. At 7 p.m., I have 6 inches of snow. So compute the slope. Well, for the 100th time, how do I find slope? Well, slope is my change in y over my change in x. It's just y minus y over, so I did 6 minus 4. So that means 7 minus 3 needs to go on the bottom. So my rate of change is 2 over 4 which is also known as 1/2. So what's 1/2 representing? It's my change in y, so it's inches per hour. So each hour, for every hour, another 1/2 inches of snow falls. That's what my slope is telling me. For every x, what happens to my y value? Another 1/2 inches of snow falls or accumulates on the ground. So it's my change in y over my change in x. A plumber has a set fee. That's a set fee. That's a one-time fee. Oh, easy there. Easy there, computer. I have a set fee. And then I charge by the hour. That should say hour, sorry. By the hour for repairs. So I have a set fee and then I charge by the hour. So the slope, well, first of all, let's say what the slope is. The slope here is 75. That's my slope. That's my rate of change. So is that the set fee or the hourly charge? So each hour, the cost increases by $75. And then the y-intercept is what? That's the one-time fee. There is a set fee. There is a one-time fee of, that's the plain old number, of $40. So you got to remember, the slope is the number in front of the variable, and the y-intercept is the plain old number. Okay, we're going to skip number 5 just to make this video a little bit shorter. And let's look at number 6 here. So AT&T charges $40 for 3 gigabytes of data. For each additional, that's telling me slope, the price increased by $15. So let's make a table here. I've got gigabytes of data and cost. So notice I have 3 gigabytes of data for $40. We already knew that. So now I need to realize what's the pattern here. Well, the pattern appears to be add 15. The pattern here appears to be add 15. So plus 15 plus 15. Well, I need my y-intercept, so I've got to work backwards. So how do I work backwards? Instead of adding $15, that looked rough there, I'm going to subtract $15. I'm going to subtract another $15 and then another $15. Again, sometimes the y-intercepts don't make sense. Like this case, my y-intercept is -5. So my cost equals $15 per gigabyte, and there just happens to be a -5 there. I know it doesn't make sense because really the function starts here. This is where the function starts, and we go up from there. So g really has to be bigger than 3, but to make the function work, I need that y-intercept of -5. Doesn't make sense, but that's the y-intercept. So remember, we always have tables at our disposal. We can always use tables to figure out the rate of change in the y-intercept by just applying that repeated addition. And we'll end here with number 7. When someone buys a car, the minute you begin to drive it, the resale value goes down. It drops drastically. The minute you drive a car off of a car lot, it becomes a used car and loses a lot of value. So here's a function that models the value of a car. Y equals 20,000 minus 1200x. What's the slope and the y-intercept? So let's start with slope. What is the slope telling me here? Well, the slope is a rate of change. Each year, what happens? Each year, the value decreases. Why does it decrease? Well, it's negative by $1,200. That's what the slope is telling me. Each year it decreases, that's right there, by $1,200. Whereas the y-intercept is the initial or starting. The initial cost or the initial value of the car was how much? Was $20,000. That's what the y-intercept is. So from this lesson, I need you guys to understand y-intercept is the starting amount And the slope is the rate of change. It's for each, for every, whereas the y-intercept is that one-time phi. And that ends our unit on linear functions, folks. We're going to practice and then before we take our test. And I'll see you guys soon.